Alright, this is going to be section 2.3, just working with different properties of trigonometric functions. We've defined trig functions earlier for the unit circle, which was specifically a radius of 1. And remember, that was just sine of theta equals y, cosine of theta equals x, tangent of theta equals y over x, so on and so forth. Where the only difference in this definition is we have a radius that's not necessarily 1 for a specific unit circle. The radius can be anything. So the only change is instead of just being over 1, we have over r for a radius. And then, of course, remember, this one's the reciprocal of sine, so the only thing that changes, instead of being 1 over y, it's r over y. And instead of being 1 over x, it's r over x. So we'll write that down. So pause the video and write that down. That's with any given radius. Okay, and the next thing we're going to do is we're going to spend some time looking at the properties, the domain, the range, and the period of all of our 6 trig functions. And your sine function is going to be this first one, cosine function is here, and then your tangent. But before we get too far into this, and I'm going to spend some time on that, I want you to look at this applet off of the internet. And so if I choose the sine function, so here's our unit circle we've been working with, and I hit start, as I move my way around the unit circle, if I were to plot x and y values at particular points, you can see over here to the right it's graphing my sine wave. And that's pi halves, pi and 3 pi over 2, and then right here is going to be 2 pi. So for this left side to go all the way around the unit circle, which is 360 degrees or 2 pi radians, this makes the period of the sine wave. So, and also let me go back. And we'll do cosine. So if I just take the sine off and we start over and do cosine wave, you can see these values going to work its way around the unit circle. And we start, the difference is sine wave went through the origin, cosine wave starts here. And that's going to be 2 pi right there. So we'll stop. And then, of course, tangent, we'll watch this way around. Actually, let me take the cosine off. Restart that. I had the cosine on. Okay, so the tangent for it to go from here to here is going to have a period of just pi before it starts repeating. So keep that in mind when we see these graphs in its entirety. So let me grab a highlighter. Okay, the domain, remember that's all of your x values. Well, that's going to be from all real numbers because it's negative infinity to positive infinity. It can go on and on in either direction. The range is the y values. You can see it doesn't go any further than positive 1 or any lower than negative 1. So that's why the range, that's the y values, negative 1 to 1. And the period is 2 pi. So for it to go all the way around the unit circle, that's going to be a period of 2 pi. Our cosine value, and we can see that the sine value goes to the origin right there, 0, 0. The cosine starts at 0, 1 right here, but the domain are all real numbers, remember, because this extends in both directions, negative infinity to positive infinity. The range, once again, doesn't go any higher than 1, and the y value's not any lower than negative 1. And once again, the period is 2 pi. Okay, we get over here to our tangent, and the domain are all the x values except for our intervals at right here, where it's undefined. So it's negative infinity to positive infinity except for these places where it's undefined, which is going to be multiples of pi half. So the odd multiples of pi half. So that's here, pi halves, 3 pi halves, so on and so forth. Then we look down here, and remember sine's the reciprocal function of cosecant x, and we recall that right here, 1 over the sine of x. The domain is all of the x values except for where it's undefined. Okay, so it's undefined here at these blue lines. The range is going to be the y value, so it's going to be from negative infinity, so that's down here, from negative infinity to negative 1, that's this, okay, and from positive 1 to infinity, so that's the y values. Remember, your range represents your y values. Your period is 2 pi, so from here to here gets us all the way around the unit circle, so that's a period of 2 pi. Let me move all that off the screen. Okay, and then similarly with the cosine of x, its reciprocal function's down here, and basically if I was to draw a cosine of x with it, it looks like that, right? And for the sine of x, remember our sine wave looks like this? So we can see how they're reflected right there. So your domain is all x not equal to the pi halves right here. So you got the pi halves, and then you got multiples of pi halves right there. And the range is the y value, so it's negative infinity, and it stops at negative 1, so that's your range. And then for this one, it's going to be from 1 to infinity. And your period is 2 pi. All of that occurs in 2 pi. Okay, now just like tangent has a period of just pi, its reciprocal function cotangent has a period of pi. This one is going to increase to the right, and then the cotangent decreases to the right, meaning as I write from left to right, I'm going down. So this one's an increasing function left to right. The cotangent's a decreasing function when I'm right, left to right, but most importantly, it's going to be pi. It's going to be the period. And we have to remember these two have a period of only pi. All of these have a period of 2 pi. And so this one had odd integer multiples of pi over 2. This one has multiples of pi. So you can see the undefined line is at pi, at 2 pi, 3 pi, so on and so forth. So those are some of our characteristics of our 6 trig functions. Okay, the next thing we're going to look at is periodic properties, and the definition's right down here. A function f is periodic if there's a positive number p such that whenever theta is in the domain of f, so is theta plus p. And so a function evaluated at theta plus p is the same answer we would get if we evaluate the function at theta. So all this is saying is if you have sine of theta plus 2 pi and it's periodic right here, then that's the same thing as just evaluating the sine of theta. Let's look at that. Sine of pi over 6 is 1/2. If you look on your unit circle and you find that, that's 1/2. Well, the sine of pi 6 plus one entire revolution, it's almost similar to like the coterminal idea, right? You go all the way around one time, it's going to be in that same location on the unit circle. You'll get the same value. It's a similar property with periodic property. So basically you go around 2 pi, and it's the same evaluation as sine of pi over 6. So it's just in the form that theta plus p, a period. And we look at a second example, cosine of pi over 6. If we look on our unit circle, that's going to be square root of 3 over 2. Okay? If we had, and this format is theta plus p, well, this is just 2 times around, right? The unit circle. So it's going to be the same evaluation as the cosine of pi over 6, which is just going to be square root of 3 over 2.